A very good day to the panel of CITREX 2021. Me, myself, is Shanti Ravichandran from the faculty from College of Engineering, University Malaysia, Pahang. The title of our research is Optimization of Reaction Parameters of Cyclodextrin glycosyltransferase from Bacillus llichnjformis on cyclodextrin production. So the inventor of our research is Dr. Rohaida B. Chayman, and the co-inventors are me, myself, Shanti Ravichandran, and Mohammad Taufik bin Abdul Rahman. So the introduction of CD. So cyclodextrins are a family of cyclic oligosaccharides consisting of macrocyclic ring of glucose subunits joined by alpha-1,4 glycosidic bonds. So that CD is enzymatically modified such using CGTase that they encapsulate other hydrophobic organic substance aiding solubilization in water. So the common of CD are cyclomalta-epsosa alpha CD, cyclomalta-epsosa beta CD, and cyclomalta-octosa gamma CD, which consists of 6, 7, and 8 glucose units respectively. The nonpolar hydrophobic molecule interacts with the nonpolar groups in the interior of cyclodextrin, while the polar hydroxyl group on the exterior surface of cyclodextrin are hydrophilic. Thus, these features help to improve gas molecules' chemical and physical properties. So, the process parameters such as reaction time, pH, temperature, which are the most significant factors in the CD production, were chosen for the optimization process to obtain high production of CD. The objective of our research is to optimize the reaction parameters of CGTase from Bacillus llichnjformis on the CD production by response surface methodology, which is RSM. So the motivation of our research is CD is significant in food technology and human nutrition, as they act as a dietary fibers which are useful for controlling body weight and body lipid profile. They are prebiotics where they improve the intestinal microflora by selective flow fibrillation. They form inclusion complex and enhance the aqueous solubility, physical chemical stability, and bioavailability of the drugs. Thus, the optimization of process parameters such as pH, temperature, and reaction time on the production of CD using CGTase from Bacillus lachrymphormis was investigated in the present study using RSM to attain the desired response.
So, what is the benefit of this CD application? So, the most noticeable features of CD is the ability to form inclusion complex with a very wide range of solid, liquid, gaseous compound by a molecular complexation. The inclusion of CD exerts a profound effect on the physical and chemical properties of a gas molecule, which are not achievable otherwise. Some of the benefits of CD application are the solubility enhancement of insoluble gas, stabilization of labile gas against degradative effect of oxidation, control volatility and sublimation, uh, physical isolation of incompatible compound, taste modification by masking flavor and odors, and control the release of drug and of flavor. Therefore, the CD are widely used and applied in industries such as food, pharmaceutical, cosmetic, agriculture, and textile. CD industry concentration are relatively high. This is due to the number of manufacturers is less than 100 around the world. Japan and the Western European are the high-end producer, while China is used to produce a lower-end production of CD. The lower-end CD is used to be lower quality but a better price than the high-end CD, and the target market of this lower-end production is to the developed country and lower-end international market. According to Market 2019, in the next 5 years, CD market will increase 2.8% revenue the size of market will reach USD 240 million by 2034 from USD 180 million in 2019. This shows the increase of demand for commercial CD. So how we synthesize our CD? First, we mix 200 ml of pH buffer with soluble starch in 50 ml of conical flask. Then we dissolve the mixture in a steam bath. We cool down the mixture to room temperature and add 0.1 ml of CGTase. Then we incubate the sample at a certain temperature and agitation rate. Then we analyze our CD product by cooling down the reaction at room temperature, then add 0.1 ml of HCl to stop the reaction. Then we remove the unreacted of starch using a filter paper and take the filtrate, then insert into the HPLC.
Moving forward is the result and discussion. So the figure shows the response and control curve of time versus temperature with constant level of pH 6 and constant agitation rate of 100 rpm. So the highest CD production was 06.04 mg per milliliter was observed at 5.68 hours. The production of CD improved significantly by increasing the reaction time. The CD increment occurred when the reaction time was increased due to the frequent binding between the enzyme and the substrate, thus improved the reaction process for the production of CD. So by providing adequate time for the contact between enzyme and substrate molecule in reaction mixture, an efficient reaction has occurred for the production of CD. However, the CD production reduced when the time prolonged because the enzyme substrate equilibrium has taken place and affected the amount of CD here. This was due to inhibition of product occurred when the CDs accumulated in the reaction mixture. The CD accumulated on the enzyme's active site and avoided the binding process of the substrate to the enzyme active site. Thus, this occurrence affects the production of the CD. So the temperature also plays an important role in the production of CD. So as you can see, the CD production was improved by increasing the reaction temperature from 30 to 40 degrees Celsius. So based on the figure, temperature 40 degrees Celsius was chosen to be the best temperature for the maximum production of CD. This is because the kinetic energy increases when the temperature increases, assisting in the frequent collision between enzyme and substrate molecule. Hence, this phenomenon resulted in high production of CD. However, when the temperature is further increased, the production of CD decreases. So this is due to the denaturation of enzyme at the high temperature. Therefore, substrate molecule unable to bind to the active site of enzyme and consequently produce low CD. It was actually found that extreme temperature altered the size and the shape of active site, resulting in lower CD production. Therefore, it is suggested that moderate temperature, which is 40 degrees Celsius, is favorable for production of CD. So, this figure shows the response and control curve of reaction time versus pH with a constant temperature of 40 degrees Celsius and constant agitation rate of 100 rpm. So, pH 6 was found to be the optimum pH for the highest production of CD with a concentration of 6.04 mg per milliliter. Extreme pH values were not found suitable for the CGTase activity. It actually needs a near neutral pH for its highest activity. This is because pH can affect the enzyme structure, resulting in enzyme denaturation. So the production of CD is lower in high acidic and high alkaline medium. So in the high alkaline medium, due to the abundant hydroxy OH negative ions in the reaction mixture, the production of CD has decreased. Consequently, OH minus bind to the amino group NH3 plus of the enzyme. Hence, it prevents the substrate to be placed at the right orientation of enzyme active site. Besides, the high pH could also cause deprotonation of tyrosine residue amino acid which affected the glycosylation reaction to produce CD. Therefore, it can be concluded that it is a near neutral pH, which is pH 6, is also most suitable in the present study to increase the CD production. Optimized reaction parameters on CD production are summarized in the table. So the reaction time 4.05 hour, pH of 5.60 and temperature of 39 degrees Celsius was chosen to produce the high amount of CD. So as the response is our CD concentration, which is mg per milliliter. So from the RSM, we have predicted 5.92 mg per milliliter will be produced. And after the validation experiment was carried out, the actual value of 6.20 mg per milliliter was observed. Thus, the CD production after optimization, which is 6.20 mg per milliliter, showed 2.3-fold higher than the value before optimization process, which is 2.52 mg per milliliter.
The conclusion for the study is the optimization of reaction parameter on the synthesis of CD by CGTase Bacillus llichnjformis via RSM has been successfully investigated. The optimization reaction results in high production of CD compared to production before the optimization. Reaction time 4.05 hours, pH 5.6 and temperature 39 degrees C is the optimum condition for producing 6.2 mg of CD. For a suggestion, scale-up study must be conducted using a pilot scale production before we apply in industry. Next, the immobilization approach can be used to the enzyme where it provides the resistance for the enzyme. That's all for me.